So we're going to classify conics. And that means we're going to look at the equation all multiplied out like this, or it could be in the standard graphing form. It could be in that form. But we're going to look at it. We're going to know what picture it would make when we graphed it. So there's a few hints. If it is in this form, the ax squared plus bx or by squared plus cx plus dy equals e, or plus e equals 0. Sorry, I can't read it. If it's in this form, it's like all multiplied out. This is like prior to us doing complete the square. Then you're going to look at just the a and the b values. The a is in front of x squared and the b is in front of y squared. You're going to look at those values, and if a equals b, then it may define a circle. If a and b have the same sign, but they do not equal each other, we're talking ellipse. Same sign, but not the same number. If a and b have different signs, one's plus, one's minus, that might define a hyperbola. And then we haven't learned about parabolas yet. We're doing that later in class today, but we can still classify it because parabolas are different than the first three. Parabolas only have either x squared or they have y squared. They don't have both. So if you're missing a or b, if one of them's 0 and you're missing it, then it was a parabola. So we look at the first example and we see that a is 3 and b is 2. No, negative 2. A is 3 and b is negative 2. Different signs. What's that one? Hyperbola. Question 2, we've got 4 and 4. Same number. So it's going to be, it might be a circle. 3, we have 7x squared, and there is no y squared. So what will we have here? Parabola. Number 4, we've got negative 3 for A and negative 4 for B. Those are same sign, but different numbers, which is ellipse. When you guys take a quiz or a, what's the second thing? Quiz or test, I might have you tell me what that's going to be, and you have to know how to spell it correctly or Canvas marks it wrong. So please, ellipse, 2 L's. Number 5, we've got negative 4, positive 4. Different signs. Hyperbola. Nope. If they were both negative or they were both positive, yes. But since we have different signs, it's going to go away from each other. Now the rectangle would be the same. It would be like a square. What? It would be or wouldn't be? It would be. It could be the same with the exception of that the one of them would be plus and would be minus. So our equation would be a subtraction equation. And circles are addition. Yes. Then we wouldn't have a conic at all. Okay. Then if they were both 0, if we had like an X and a Y, it would be like a line, linear. Okay, so how about negative 1 and negative 1? That will be a circle. And I say will be, let me rephrase it. Don't know if you catch me saying this. That might be a circle. Okay, so number 7 is not in the form from the front of the page. So it's in a different form. That form kind of looks like what we were studying recently, though. What do you guys think this is? Why do you think it's a hyperbola, which is correct? What makes it look like a hyperbola and not an ellipse?
It's got the x's first. Subtracting.
It's because of the subtraction. It's the subtraction that makes it a hyperbola and not an ellipse. I got to rearrange myself. Okay. The next one. What do you guys think? Ellipse. that is in the standard graphing form that we've been doing. They don't have X first, they have Y first. It doesn't really matter because it's addition and you could switch them around. All right, we're on number 9. That might be, we've got A squared is 20, B squared is 1. Might be same sign, different numbers. Ellipse. Number 10. What do you think? Circle? Who said that? Lydia? Y'all wearing black masks too. So this one is a circle, or might be a circle, but it's not in either format. It kind of looks like it's set up as an ellipse right now, but the fact that they're both 5s underneath would make it stretch the same. And remember, when we do circle equations, it would be like x squared plus y squared equals 5. So that would be a different format if we were doing circles, just as a reminder. All right, number 11, we've got 4 and 9, same sign, different numbers. Ellipse. Number 12, -3, -3, exactly the same number. Circle. Number 13, we've got b squared is 5. Parabola, there's only one, so parabola. And 12, we've got 2 and -4. Different signs. Hyperbola. So now I was talking about that these may define what we answered. And I want to show you one of these in here actually does not define what we thought it would be, but you won't necessarily be able to look at it and tell. I just want to show you number 9 is not actually an ellipse. So let's look at number 9. Number 9, if I set this equal to, like make it say equals 1, if we put it in the actual format it's supposed to be, I would first take away 10 if I put it into its standard graphing form. And then to get it to equal 1, I would have to divide by -10. So now I have, I'm going to simplify this a little bit different than just dividing by -10. That would give me -2x squared. But since I need the number in the bottom, I just made it divide by a half because that's the same thing as multiply by 2. And then I would get minus y squared over 10 equals 1. So what's something different about this equation that never happened when we did ellipses before? What's something about this equation that never happened when we did the ellipses? What? So the half is different, but that is not what's making it not an ellipse. Because I can still find the square root of a half. That would be like plus minus a fourth, and it's just really teeny tiny to graph. So it's not that makes it different. Which negative sign? So the middle negative sign would make it a hyperbola, but there is a second negative sign here. Like they're both negative, and we haven't had any that are both negative. So in order to get rid of that negative, I'm going to multiply both sides by -1. So that makes positive x squared over a half plus y squared over 10, but then it equals -1. So now I'm like, I can't have it equal to -1. If I graph this, nothing will show up, and this is why. You guys know that if we square any number at all, if I square any number at all, always equals positive. And then I'm going to divide that number by half, it's still going to be positive. If I square any number at all, it's going to be positive. Divided by 10, still a positive number. How am I going to add two positive numbers together and equal -1? How's that possible? It's not. That's why this one secretly is not even a thing at all. Like this equation could never, ever possibly work. Unless we have imaginary numbers, and then we wouldn't have a conic either. Now, I will not give you one that isn't what you think it should be. I'm not going to give you one like number 9, okay? The ones that I give you will work. They'll all have conics. But I just wanted to explain to you why the words and why I was being kind of like, I don't know the vocabulary word I was going to say, but why it says it may define. It doesn't mean it always does. Okay, that's the end of the first notes. Got it? So one of your worksheets, you're going to look at equations, say what they should be, look at a few more equations, say what they should be, and put them in the correct form. No graphing. So that's the first worksheet. The second worksheet is all about parabolas. Parabolas. So while you're getting that open, if you haven't opened it already, I'm just going to draw a couple parabolas up here. If you've already opened it, I'm just drawing a couple parabolas up here. Let's see, you guys, we have parabolas that open up. We have parabolas that open down, right? And in chapter 1, when we talked about inverses, we had parabolas that open right, and we had parabolas that open left. So we really have not done many of the right and left opening kind. We're going to do a little bit more of those today. But then there's a couple things about parabolas that we've never discussed in this class. You might have discussed it in class last year, but most classes did not. I know that my class did not discuss this last year. There's more to the parabola than just that thing, the curve. Just like when we had the ellipses, we had the ellipse, we also had the center point, and then what else did we have with the ellipse? The foci. We had those 2 focal points. And with our hyperbolas, we also had foci, the focal points. So we're going to have the same thing with parabolas. There's just one focus, one focal point per curve. So the focal point is always going to be on the inside of the parabola. These are 4 different parabolas. These would be like 4 different questions. They're not 2 of them at the same time. Here, I'll make some more just so you're not thinking there's just always 2. Each parabola will have a focus, okay? And then, I'll do one over here too. Each parabola will also have some, ooh, that was really bad. Each parabola will also have something called a directrix, which is written lower, but I'll just put it in the picture. A directrix, which is a line outside of the parabola. I'm drawing the directrix for a bunch of these parabolas here. You don't have to. I'm just showing you guys pictures here. So each parabola will have a point on the inside and a line on the outside. These focal points and directrices, I don't know how to say multiple directrixes. They are just used when you go into higher level math. If you go into some sort of engineering, it's possible, like engineering where you would need parabolas. It's possible that you could use the focal point for something important. Anybody driven a car? Okay, so you actually may be a teeny bit familiar with focal points and you just don't realize it. That's your sweet sports car. Okay. And then when it's nighttime, yours is really cool. You've got these lights that just come up, they flip up. Yeah, it's cool. Okay. Inside of this light, oh gosh, now I got to really think here. Inside of that headlight, there's something that makes the light turn on, like a bulb. There's an actual light inside there. Yeah. So the light itself doesn't just point straight forward. That's not how these work. And another example would be just a flashlight. The light itself doesn't just point forward on its own. There is a parabolic reflector right here. And that's part of a parabola. There's a parabolic reflector. Maybe your headlamps look more like this one here. Let me make it just a big one. The pink part's like a parabolic reflector, and the light, it shines everywhere, just like a sunshine. It's shining everywhere, but when it hits that parabolic reflector reflects it out, so that light is more concentrated where you need it. So that parabolic reflector is the parabola, and guess what? The focus is our light. So that focus is actually really important when we want to aim something. And it's used in other things too, like satellite dishes, things that try to talk with aliens and stuff, you know. That's a whole lesson on real life application of that. We're not going to really do any real life application. So here's the vertex form of a parabola, and there's two different versions of this. There's y equals the one that we're used to doing, the ones that open up or down. Y equals. It used to say, when we did vertex form, it said y equals a times x minus h squared plus k. That's what we're used to. Now we've taken a and we've kind of broken it down a little bit. A is now equivalent to 1 over 4p. Because I'm going to need that p value. I'm going to need that for when I go down further in the notes. So we're going to need to know that p value. The other version of our equation would be the kind that open left or right, and that's going to start with an x equals. We still have 1 over 4p, but now it has y minus k squared on the inside, and now on the outside is the h. So like all the x's and y's completely switch spots. That's what's going to make it open left or right. Down below, there's some information about opening left or right or up or down, and I forgot to type in 1 over 4p is greater than, I forgot to type in what is greater than. There should be a 0 right here. I'm going to do it in a different color so it stands out better. There should be a 0. That's not a different color. Right there. There should be a 0 for each of these. I don't know what happened. Just didn't make it somehow. You can think about if it opens up, it's positive. That's what I'm trying to say by 1 over 4p is greater than 0, positive. Or it opens down, it's negative. And when we were doing transformations before, you should already know if it's positive, it's going to open up, or if it's negative, it's going to open down. And the same thing works for left or right. If it's positive, it's going to go to the right because that's the direction of positive x's. If it's negative, it'll open to the left. Now, before I do vertex, I forgot. Well, I didn't really forget. I'm going to add in something we've already covered. So I didn't put it in here, but I'm going to go over it. Do you guys remember doing the AOS, axis of symmetry? So the axis of symmetry goes through the middle of the parabola. It's that line of symmetry. It's that reflection line. For the axis of symmetry, if it opens up or down, it's going to be x equals h. But the axis of symmetry, if it opens left or right, is going to be y equals k. So those switch when it opens left or right. The vertex. If the parabola opens up or down, left or right, the vertex is HK, no matter what. But the H and K are in different locations in the left-right equation. You guys remember when we found the vertex for the first equation, for the one that we've used more recently? H is opposite and K is the same sign. For this one, H is going to be the same sign. And K will be opposite because they've switched spots. But we still graph the X value, then the Y value. The focus is P units away from the vertex and inside the parabola. I'm going to add something to what it says for the focus. It's P units away from the vertex and inside the parabola. I'm going to say in the direction of the opening. In the direction of the opening. So if it's opening left, then my focus is going to be P units away to the left. The directrix is an equation of a line P units away from the vertex, but it's outside of the parabola. It must be an equation. I'm going to add on something to this. It is perpendicular. Perpendicular to the AOS. It's perpendicular to the axis of symmetry. I think that's all I need to say. It's perpendicular to the axis of symmetry. Okay, we're going to do question C first. We're going to just skip A and B. They're like super easy. There's no transformations really, so we're just going to skip those. We're just going to start with C. So you look at question C, it is not in the format that we need it to be in. But we do know it's a parabola because only X is squared. The Y is not. So we have to complete the square. You only have to do it with X. X is the only one that's squared. So I'm going to start with completing the square with the X. I'm going to add the square to both sides. The number that completes that square will be 9. And I get X minus 3 squared equals 4Y minus 20. To be in vertex form, we have to have it either Y equals or X equals. Whatever's not squared, we're going to make it equal to that. So I'm going to get Y by itself by adding 20 and then getting rid of the 4. So I'll have 4Y equals X minus 3 squared plus 20. And then to divide everything by 4 is the same as multiplying by 1/4. So my equation Y equals, I'm going to put 1/4 in front, not divided by 4. I'll put 1/4 in front. X minus 3 squared plus 5. So that'll be my equation. Everything that we've already learned about parabolas still can be used. So if I asked you to find the y-intercept, I'm not, but if I asked you to find the y-intercept, how would you find the y-intercept? Plug in 0 for x, right? The y-intercept. Or if I asked you to find the x-intercept or ceps, what would we do? Plug in 0 for y and solve. I'll come back to that in a moment. I forgot to add axis of symmetry as a line, but in your assignment it says find axis of symmetry. So we might as well just find it. And that'll help us find our directrix too. So it's good that we're writing it down. We can either start with the axis of symmetry or the vertex. It doesn't matter which one we start with. Let's just start with the vertex. Katie, can you tell me the vertex for this one? 3, 5 is correct. So if 3, 5 is my vertex, then Grace, what would be my axis of symmetry? I hear you saying 3, but I don't hear what else you're saying. X equals 3, yes. So the axis of symmetry is always an equation. If you don't have the x equals, it would be wrong. I'm going to go ahead and graph those or sketch those on the graph. 3, 5. X equals 3. This opens where? Up. And we know that it opens up because it's y equals and also because it's positive 1/4 in front. Next thing is the p-value. So my p-value, a equals 1/4p is the formula. So in this equation, a is 1/4. So I need to find p. You might be able to look at it and be able to tell me what p is, or we might have to cross multiply to solve. Can anybody tell me what p is? P is 1, yep. Once we know our p-value, we're going to use that p-value to find the focal point in the directrix. And what I said in our directions was the focal point is going to go in the same direction as the opening, and it's going to affect the vertex. So it's going to be 1 unit up from 3, 5. So if I'm looking at my ordered pair, my 3, 5, and I'm going to do 1 unit up from 3, 5, what variable am I going to put 1 on? Am I going to add 1 on? The y, because I'm doing 1 unit up. That's why. So my focus must be at 3, 6. I can also do this visually. Go to the graph, go 1 unit up, and write down that ordered pair. Okay, so you can do it on the graph. You can do it with the equation. The directrix is outside of the parabola. It goes in the opposite direction that the focus went in. So the directrix is going to go, instead of up, we're going to do the opposite of up. And then it's also going to affect the vertex, but it's a line. So since we're going down 1, that's going to affect my y value again, and I'm going to get 4. Because it is perpendicular, can I use this sign for perpendicular? Do you guys remember that perpendicular sign? It kind of looks like an upside down T. I'm not looking at your faces. Do you guys remember? Okay. Good. One person remembers. Awesome. So the perpendicular, by that time I could have just written the word, perpendicular to the AOS. So our axis of symmetry is x equals. That means the directrix is y equals. So that's what I'm talking about when we're talking about perpendicular. If one's x equals, the other's y equals. And I go to the graph, and at y equals 4, 1 unit lower than the vertex. That's our axis of symmetry. Okay, one more step. We have to graph the parabola. And how many points do I have plotted that are actually on the parabola? 1. And how many points should you have minimum? 5. That means I need 2 more plus their reflecting points. Okay? There's different ways we could do it. We could find the y-intercept and the x-intercepts. There's another way we can do it. When we did this stuff before, if it was in vertex form, we used a transformation table. So I'm going to use a transformation table. If you want to do x and y intercepts, it's going to be up to you. But I'm going to talk about x and y intercepts after I do my transformation table. Okay? So I'm going to do the transformation table. 1/4 x minus 3 plus 5. I'm just going to copy down that equation because I can't see it. So my transformation table, we start with parent function points. -3, -2, -1, 0, 1, 2, 3, and then square all those. 9, 4, 1, 0, 1, 4, 9. parent function points. And then that 1/4 is affecting the y's. So we multiply by 1/4. That's a shrink. So I get 9/4, 1, 1/4, 0, 1/4, 1, 9/4. And then outside for the y's, I'm adding 5. Outside for the x's, I am adding 3. 2, 3. Okay, what is 5? 5 is 20/5. So I'll have 29/5. I will have 6. No. Yes, 6. And then I'll have 21/5. What am I saying fifths? Fourths. I'm sorry. 4ths. Then I'll have 5. Then I'll have 21/4. Then I'll have 6. And then I'll have 29/4. It's okay to have something like 5 1/4 written over here, but when we have a quiz, you have to type it in Canvas. I'm going to want it as an improper fraction, so I don't have to worry about spaces and how you write a mixed number. Okay, then I'm going to go plot those. So I'm going to zoom out. If you don't have all these ordered pairs, I'm zooming out. You might not be able to see them very well, but you should have the top number, and you guys are good at making tables. So then I have 0, and then 29/4 is like 7 1/4. Then I've got 1 6. 2 is 5 1/4. And then we've got those reflecting points. Okay. So I did this with transformation table. I got plenty of points. I connected it. I even got more points than I needed. Overachieved a little bit. If you chose to do it with x and y intercepts, you plugged in 0 for x to find your y-intercept, which I wrote over here. That's how you do it. If you did that, can anybody tell me what answer you would get? Because it's in my table somewhere. The y-intercept. Anybody see it in the table? Here's my vertex. Anybody see the y-intercept in the table? Brady, do you see it? I can zoom in. Where's the y-intercept in the table? Plug in 0 for x.
0, 29,
Yeah. So there's your y-intercept. So I did get that, even though I didn't actually try to find it. I did find it. What about x-intercepts? So I'm sorry, let me rewind just a teeny bit. If I'm finding the y-intercept by just like finding it, not with a table, I would find this pink point, and then I could have its mirror point. So then I would have 3 points on the graph so far. So if I find the y-intercept, that gives me 2 points. I still need more points. What would happen if I found my x-intercepts? Look at the graph. What would happen if I tried to find my x-intercepts? You wouldn't get any. So then you'd still have to go back and do more work to find the rest of the points, which is why I recommend a table. You could still find your x-intercepts or y-intercepts if you want, but I don't recommend it because you might not get everything you need. Table will give you everything you need. Okay, that was really fast. The new stuff that we need to know is p-value. There's a formula for that. Add the p-value, subtract the p-value. And then everything else, for the most part, is review. All right? We're going to do one more, but this one is all backwards because this one's going to be the other kind. So we're going to start here, and you're going to say it's not in the correct form. What should we do? Well, I am going to get x to the other side because I have to do what? What's it called? What? Complete the square, yes. And how do you know which variable to do it with? It's the one that's squared. That's how you know which variable to use. So now, yes, we're going to move the x over, and I'm going to move that 9 over as well. So I'll have y squared plus 2y plus a square equals negative 10x plus 9y, or plus 9, sorry, plus a square. Complete the square, 1 goes in. Y plus 1 squared equals negative 10x plus 10. And then we're going to solve for x. I'm doing it super fast. And when you've completed the square correctly and you've set it up into be vertex form, you should have x equals negative 1/10 y plus 1 squared plus 1. So this should be pretty easy. It's exactly the same as the question we did, which we've been doing for a long time, except everything's backwards. So the equation, which you can get from the first page, I'm going to write down. If you don't know it already, you should write it down every time we use it so that you can learn it. The equation is x equals 1 over 4p times y minus k squared plus h. We're going to find our vertex, and we're also going to find our axis of symmetry. Just make it on the same line. It doesn't really matter which one you find first. So our vertex is always HK. Always HK. Kevin, you got a guess for the vertex? 1, negative 1 is correct. Very good job. So 1, negative 1. So what you want to do is you want to keep this, you want to do the opposite of what the sign is with the K, but you want to keep the same sign with the H, but H has to come first. So we looked at that 1. The 1 has to come first, and then negative 1 would be the K value. So our axis of symmetry is also backwards. Normally it's x equals, so this one's going to be y equals, and then our k value, negative 1. So go ahead and graph that. 1, negative 1, and then y equals negative 1 is a horizontal line. The direction of the opening, because everything's switched, it's either left or right. So we look at this 1 over 4p and determine, is it going to be left or right? Negative, so it'll be to the left. Negative would be to the left. Next is our p-value. So we do a equals 1 over 4p. That's the formula. Whatever our a is, set a equal to 1 over 4p. So our a is negative 1/10. And for me, I might not be able to look at this and be like, oh, that answers whatever it is. So I'm going to cross multiply. When I cross multiply this, I get 10 equals negative 4p. Divide both sides by negative 4. P equals, I get negative 5 over 2. Negative 5 over 2, which is negative 2.5. So when I go plot it, it's going to be 2.5. So if we're using our information to find the focal point, then I'm just going to use what I've already written down. The p-value is going to go in the direction of the opening, so it's going to go to the left, off of the vertex. Because it's going to the left, am I going to put it on the x or the y part of the vertex? The x part. So that's negative 2.5. When I go and I plot it, I can either find that point and plot it, or I can also go to the graph and just go 1, 2.5, negative 2.5. Let's see, that is negative 3/2. Negative 1. Negative 1.5, negative 1. And then the directrix is going to be in the opposite direction as the opening. And it's still going to go off of the vertex, but it's a line. And that line is perpendicular to y equals. So this line is going to be what equals? X equals. And then we are still changing the x value, but we will be adding 5. I just put plus minus. We'll be adding 5/2. And so 1 is 2/2 plus 5/2 is 7/2. Or you could go plot it and find out that it's at 3.5. And then write the directrix from your graph. Okay, so we have everything done except for the graph. I'm going to do it with a transformation table. Again, you can get points other ways, but I'm going to recommend a transformation table because it definitely gives you the vertex and points around the vertex. I'm going to copy my equation real fast so I don't have to keep looking. Okay, so my transformation table. Since everything is backwards, this is what I'm going to do on my transformation table. When I look at the equation, the input is y and the output is x. So when I plug things into the equation, when I plug things into like the y, the equation is like y squared. The parent function is y squared. So I'm going to plug in -3, -2, -1, 0, 1, 2, 3, just the same way that I did it before. It's just the top of the column looks different. So I'm going to get 9, 4, 1, 0, 1, 4, 9 in the y's, or in the x's, I guess. Okay, do you guys understand why I switched the letters at the top? So I didn't have to switch all of that. I mean, I could have put x first, but x is not normally where we plug a number into. We always plug a number into the equation and solve for that number. Now I'm going to do transformations. This -1/10 normally would be the y's, but since this is x equals, -1/10 goes to the x column, which I have on that column, that's normally the y's. Does that make sense? It's just like it should make sense, but you have to really pay attention to detail here. And then my 1s to the x's, that's going to be the number on the outside, same number. To the y's, it's now the number on the inside, opposite. Because that's how we were getting our vertex also. And when you fill out the transformation table, like the first one in the far column, those should totally match with the bottom ones in that column. And then in the very far other column, they should just go in order. Should make it easy for you to do it that way. But when you go to plot them, you still have to plot in the order of x, y. So I have to write this down sometimes. I have to remember I'm plotting 1/10, -4. I'm plotting 6/10, -3. 9/10, -2. And then my center is at 1, -1. My vertex is at 1, -1. That one I've already plotted. But I just want to make sure you see how that was at 1, -1, how we have to kind of plot it opposite. And then the other 3, I'll plot those as well. It's just they're exactly the same as the ones up there with different x value or y values. Okay, I'm going to start plotting these. Got 1/10 -4. Then I've got 6/10 -3. Oops. Got 9/10 -2. And then the next ones are just like mirrors of those. We're not really turning in a whole lot of graphs here, but I do want to show you something because you might see it in my homework assignment. And I want you to understand why I'm doing this. When I look at this, I don't know if this is enough information for me to have a really accurate graph. So I might go back and I might add in another value in my table that wasn't one of the original ones because these are so like hard to graph. The accuracy I know is not going to be great. So I might pick an X value or a Y value, I should say, a Y/X value that I can multiply by 1/10 very easily. Does anybody have a Y/X value that I can multiply by 1/10 really easily? A number that I can square and then divide by 10 really easily. And graph. Let me say and graph, because all of these I could divide by 10 very easily, but and graph it very easily. Does anybody think of a number? If I plug in 10 for Y, is that what you're saying? The first number, if I plug in 10? Yeah. If I plug in 10 for Y, and I square it, I get 100 for X. And then I multiply that by -1/10, I get -10. And then what do I do? I add 1. So I get -9. And on this side, I subtract 1. So I get 9. And then I have to write it in the other order, -9, 9. So -9, 9 could be another point that I plot. Just to help me like connect these easier. And there is a mirror point. It's just like off the graph though. I did a good job of connecting them. Decent. Not so good on that side. Just a little confusion, yeah? Because you got to think about everything backwards. Okay, we need to stand up, get out of our seats. Okay, the last 3 examples, just going to give you some information and we're going to use it to find the equation. So write the equation of the parabola if the focus is at -4, 2 and the directrix is x = -6. So I'm going to go to -4, 2, doesn't have to be perfect. And that's going to be the focus. And I'm going to draw x = -6 and that will be our directrix. Okay? In order to write the equation, you're going to need to know things like the vertex. You're going to need to know the p-value. You're going to need to know the direction of opening. So once I have my focus and my directrix graphed, I should be able to answer all of this. Remember the direction, the focus is like inside of the parabola curve. So I can just go over here and say the parabola's got to be this way. So it should open to the right. And then the vertex should be, man, this is like, I need to zoom in to do a better job of drawing that. Let me erase this real fast. The vertex is right exactly in the middle of those, equidistant between the 2 things, equidistant between the focus and the directrix. So we should be able to find this vertex point. It's exactly in between those So -5. And then the y value would be 2 because we did not change up or down. We only changed left to right. And then the p-value is how far apart the vertex is from the focus, or the vertex is from the directrix. So what is that p-value? 1. Now I know that it's +1 because it's opening to the right. If it was opening to the left, I would make it a -1. Now, knowing our equations, that's going to happen from you practicing. So the equation for this one is x equals 1 over 4p times y minus k squared plus h. But I've practiced it, so I have it memorized. And then I'm going to put in x equals, I'm doing 1 over 4 times 1, so 1/4. Y minus, and then I need to do the y part of the vertex, which is 2 squared, and then plus k, which is negative, not plus k, sorry, plus h, which is -5. So that would be the equation. So question B. If you want to work faster than me, I encourage you to try to get this before I get to it. There is a focus at 6,2. And there's a directrix at y equals 3. So it's helping me find my center or my vertex. And it's also helping me know where it opens. And then I can also find my p-value. So which way is it going to open? Down. So that opening down tells me that my p-value is going to be negative. So then to get the p-value, I need my vertex first. To get the vertex, it's going to be equidistant. And between the the focus and the directrix, there's only 1 unit there. So it's in the halves. Vertex is at 6, 2.5. So my p-value is going to be -1/2. This is opening up or down, so it's y equals. The formula is 1 over 4p times x minus h squared plus k. So y equals, I'm going to do 1 over 4 times -1/2. X minus, instead of 2.5, I'm going to do, oh, that's y, never mind. 6 squared. And instead of 2.5, I'm going to do 5/2. So just be careful. I had some people in my last class not doing this correct. I'm just going to take 4 times 1/2 on the bottom. So I'm going to get -1 over 2 x minus 6 squared plus 5/2. Okay, and then the last one. We are given the vertex and the focus. And we know that the parabola has to have the focus on the inside of it. So I know that it's opening up. I don't need to find the vertex. It's given to me. So I just need the p-value, which is 3. Y equals 1 over 12 times x minus 3 squared plus 4. There's something I need to tell you. I had a student come in XH today asking a question, so I figure I should tell you guys about it. I mean, that's it for covering our stuff. I'm just going to go up to an empty spot and tell you something that may be really helpful. I don't remember what number it is in the homework, but in the homework, there's a question that gives you like x-intercept. And you have to write the equation. There's other information too, but it gives you the x-intercept at 79.0. Okay. When we have parabolas that open up or down, we could have no x-intercepts, we could have one x-intercept, or we could have two x-intercepts. How many y-intercepts will we have when it opens up or down? Only one every single time. There will not be a y-intercept. That didn't sound right. But there has to be one y-intercept, but there could be 0 to 2 x-intercepts. Now, when we look at the side to side, same thing, only everything's backwards. So there has to be one x-intercept, and then there can be 0 to 2 y-intercepts. So in the assignment, if they tell you the x-intercept, and they don't say there's 2 of them and here's 1 of them, if they tell you the x-intercept, they're telling you that is the only one. So when you go plot, I don't remember what else they gave you. She just didn't know. Like, she was like, it could be this point and this point going that way, or it could be this point and this point going this way. And that would determine how many x-intercepts there would be if you open in one way versus the other. And I said, so if there's only one given, then we're going to assume there is only one. So there's only one way of drawing that graph. Okay. So you have the rest of the time if you want to work on your assignments. There's 2 short worksheets, or if you'd rather work on your project and do your assignments at a different time, that's totally up to you. And I'm here to help you with either. Okay.